Okay. Now let's have a quick review of what we were discussing last time. Last time we were discussing another type of regression which we call binomial logistic regression. Now this is different from the multiple linear regression that we discussed before. The main difference is that in a binary logistic regression, your dependent variable is a factor, okay? It can be a qualitative variable, okay, but it's usually for classification. Okay, so there are many applications of a binary logistic regression. It can be used, for example, in the medical field, whether a person will have a heart attack or not, or a person will suffer from a particular disease or not, given certain conditions, given certain parameters. So there are lots and lots of application of a binomial logistic regression. On the other hand, the other type similar to binomial is multinomial. In a multinomial logistic regression, there are more than two levels or factors or categories that we analyze. Okay? There are also many applications of a multinomial logistic regression, but from experience, I noticed that there are more. There are more applications in whether it's in the sciences or in social sciences or natural sciences. I see more applications of the binary logistic regression. Okay, so let's have a quick review of what we discussed so far. Okay, for the binary logistic, okay, we used the data on the admission to college, right? Okay, so we were regressing. Okay, we were regressing admit. Okay, should I run this? Okay, very quickly lang, no? Okay, so let me run this very quickly. Okay, so, and then let me already run this. Okay, so we said that in modeling, what's important is that one important thing is that we do not use 100% of our data to model, to come up with a model. What's being done now is what we usually do is partition the data, okay, into two. Sometimes I've seen papers where they partition it into three. So they have the training data, the validation, and the testing data. But mostly I've seen only partitioning into two. We have the training and the testing. Okay, this is how we did it last time, where we said our data, which is my data has 400 observations. Okay, and then what we did was, okay, we look at the structure and we noticed that the dependent variable admit was as an integer. Okay, let me run this first. Okay, integer and also rank as integer, and then we converted it into a factor. So when we look at this, okay, factor na admit, factor na rank. Here we'd like to predict yung admit with two levels, no? Whether an applicant will be accepted to the university or not accepted. 0 not accepted, 1 accepted. Okay, so what we did here was to create an object called index. We're splitting our data, okay, into two. All right, and then this means replacement is equal to true. So this is more like a bootstrap. Okay, I'll explain later. Okay, kasi usually ang ginagawa din, replacement is equal to false. What's the difference between replace is equal to true and replace is equal to false? The difference between that is when replace is equal to true, when you get a sample, for example, let's say you have this URN, you have this container of 400 marbles. Okay, each of these 400 marbles represents the 400 applicants. When you take one, okay, so that will go to sample one or training. Then what you do is replace, you put back again that sample. which means that a particular sample can be picked up twice, can be chosen twice. Okay, which means that it can appear 2 times in the training data. Okay, and it can also appear in the testing data. Okay, training data. Okay, so when we run this, so we now have a trained data and a test data. Okay, we split my data, we split into 2, the one with an index is equal to 1 and an index is equal to 2, that will represent our test data. Okay, then we modeled this last time. Okay, we modeled everything, the GRE, GPA, and the rank, and it turned out that the GRE was not a significant predictor. So let me just run this very quickly. So take note, guys, I'm going through this very quickly, just by way of review. For your logistic regression, okay, ba't ako nagkamali dito? Bakit hindi nag-run? Okay. Kasi guys, ang ginamit natin LM, no? So hindi pa pwedeng LM, guys, kapag categorical yung variable natin. We have to use GLM, okay? GLM, which stands for Generalized Linear Model. And then we have to identify the family. The family is binomial. So when we run this, okay na siya. Okay, and then it turned out that the GRE variable was not significant. No? Okay, so to improve the model, we're going to delete the GRE variable. Okay, I think I need to remove files sa PC kasi bumabagal na siya. Okay. So what we did was, okay, we also discussed this last time that in fact we can ang default, guys, yung dummy variables natin, di ba nabawasan ng isa, no? Naging 3 na lang. 3 na lang yung dummy variables. So all of these variables will be interpreted in relation to our benchmark variable, our comparator variable. I mean, not variable, but the classifier, no? It's the rank 1. Okay? So, pero sabi natin last time, we can include all the ranks, pero tatanggalin natin si intercept so that our model does not fall under the dummy variable trap. And we did that last time, where we regressed admit on all the variables except -1, which means do not include the intercept. And true enough, guys, it resulted into, okay, saan na nangyari? Okay, ito, no? Ito ba yan? Okay, let me run this M1. GLM. Okay, so we have here now yung rank 1, rank 2, rank 3, rank 4, and rank 4. Okay? So, pero wala na intercept, no? Okay. So what we did was we ran the model again. This time we removed GRE because it was not significant. Okay, and which led us to our final model. Okay, so this was our final model. Okay, rank 2 is not significant. Now we said last time that the binomial, binary logistic regression and the multinomial logistic regression is quite different from the ordinary multiple linear regression, because the equation that we're given is actually the log odds ratio. Ito yun, no? Log of the probability of being admitted divided by the probability of not being admitted. So that's 1 minus P. Okay, so we looked at this last time. In fact, I recall, parang nagkakaproblema ako sa output ko, no? And I don't know, guys, when I computed for it, I was still having problems, no? But the rest of you, at least the rest of you, got it, so that's okay with me. Okay, hindi ko pa ma-decipher, guys, kung saan nagkamali yung model ko eh. Up to now, guys, as of yesterday, I was checking again, but I can't still find where that problem lie. Okay, so after modeling it, guys, we're going to predict. Okay, predict natin yung using the my model, yung trained data natin. The trained data is the data that we used. Okay, so here we created an object called P1. So it's predicting using the my model, my model, and do it on trained data. Okay, and let's see what happens. P1. Okay, let's just get P1 here, head ng P1. Okay, so these are the values. Okay, and we said that these are. Okay, so ano na to? Nag-predict na tayo, no? Okay, did I run? Yeah, I ran my model. Okay. And then predict natin. Okay. I'll just run this too. Okay, now I'm getting it 0.2822. Tama na siya. 0.2822, but when we run it, okay, anyway, I'll not go into the, tama, 2822, tama. Okay, tama na. Nilolo ko talaga tong PC ko, guys, sorry. Kasi hindi lumalabas yung 2822 last time to. Okay, so there's a way to compute yung 0.2822 kasi when you apply the formula, yung y, you're not going to get 2822. In fact, what you will be getting is negative 933,165. Okay, this is the value of y, which is the log odds. So it's difficult to interpret this. That's why we convert it into p, into the probability. And then if we apply the formula, e to the y divided by 1 plus e to the y, we get this value 2822. So that's the probability that this first observation will be accepted. So sabi natin, compare natin, probability na ma-accept siya 28% and actual hindi nga siya not accepted nga sa university. For the second observation, the probability of being accepted is 29.93%, pero na-admit siya. So here we can see that there was a discrepancy between the model and the actual. Okay, and then we can find that, guys, when we do the when we computed for this one first, we converted the values, okay, of P1 into 1 or 0. Okay, and then we constructed the confusion matrix, mali ito, Control X. They should be here. Okay, dito. Okay. So this is the confusion matrix. We're creating a tab, an object called tab 1. So it's from a table. We're creating a table. The title of the y-axis is predicted, and it's equal to pred1, okay, which is a vector of ones or zeros. I don't think I have run this. Okay, sarado ko na muna to. Then okay, so I run this pred1. Okay, so yung matrix natin ng predictions were now converted into zeros and 1. And then we compare that with the actual value. Okay, and then we get our confusion matrix. No? Okay, and we analyzed this last time. We said that the diagonals are those that have this is the true, okay, let's call this positive, no? And true negative. Okay, or we can say that this is our true positive or true negative or vice versa, depending on how you look at 0 or 1. So let's just call this true positive. Okay, so predict, guys, na hindi matatanggap yung student, tapos actually hindi nga natanggap, 208. This one is your predicted that it was the student was to be accepted, and in fact it was the student was accepted 29. Okay, true positive, okay, true negative, although in the different sense, in an opposite sense. Okay, if we let positive be equal to the accepted, so this is our true positive, this is our true negative. The rest are false positive and false negative. Okay, all right. So we can compute for the ratio. Okay, dito na lang. Okay, we said that based on our model, 72.92%. Tama yung prediction, 27% was wrong. Okay, so that was what we did with the trained data. We can do that with the test data. So sa test data, we just use yung data natin na gagamitin dito this time is the test data. Okay, same thing, and then we create this matrix, this vector of ones and zeros. So when we run this, okay, and then we create our confusion matrix, okay, where we're comparing the predicted value using the test data, okay, and then the actual test data for the row, for the column admit. So when we run this, okay, okay, so mas maliit siya kasi ang training data natin, guys, ilan lang? How many trained data natin in test is only 75 observations. So if you add this 68 plus 7, that's 75. Okay, so ang true positive natin, assuming positive is equal to being admitted, 5. True negative is 48. Okay, 48 correct predictions. So this is our false positive, predict na 2, na dapat 0 siya. Yung false negative, predict siya na hindi siya matatanggap, pero yung pala natanggap siya. Okay, so wrong forecast, wrong predictions, and 70%, around 71% yung sa test data natin. Not bad, guys. Quite close to the trained data. Remember, guys, yung test data natin, first time nakita yan ng model natin. Dito lang, no? Dito lang nakita ng model natin yan, yung test data. Okay, because when we did our model, yung my model na to, we were using the trained data. So hindi pa niya nakita si test data, pero nung nakita niya, nag-predict siya, guys. Okay, around 71% was correctly predicted. Okay, and then here we have the goodness of fit test. Okay, we're using the chi-square, and then we get a value of so this is the p-value. So the null hypothesis here is that yung overall the model is not able to predict yung admit natin, yung admit variable. So we reject that null hypothesis, which means that our model, yung my model natin is statistically okay, significant siya. Okay, so that in a nutshell, guys, is what we discussed last time. So this time naman, guys, what we're going to do is an extension of this. I'm just going to elaborate further yung resampling natin, yung ginamit natin na train at saka test. Kasi later on when we go to machine learning, guys, we're going to make use of this yung resampling. When I say resampling, where we split our data into two or more parts, and then we only use the training data to model our data, and then we use the test data to test the strength, the validity of the model that was derived from the trained data. Okay, and that's done because we don't want to overfit our model. Imagine, guys, kung lahat ginamit na natin sa ano natin, no? Lahat ginamit natin ng data natin. So paano natin matetest, guys, yung data kung wala na tayong remaining unseen data? So assuming that there will be no more additional respondents or samples, guys. So that's done. What we do is to split the data. Okay, so that's our lesson for today, guys. We'll just hopefully matapos natin to, no? Ilang 200 plus, pero karamihan naman dyan notes. Okay, so we're now going to do this LOOCV, K-fold, bootstrap. Okay, these are the different resampling methods. So this is the leave one out cross-validation, and then we have the K-fold cross-validation, and then the bootstrap. These are different methods of resampling, yung pag-split ng data. Okay, so let's learn this first, and then next, by tomorrow, guys, diba? We continue with our discussion dun sa I'm going to discuss yung multinomial first, and then yung mga or maybe not multinomial. I want to discuss first yung structural forms of regression, then a little of the diagnostics. Okay, and then next week I'm thinking of discussing magpa-panel data na tayo at saka time series. Simulan na natin yun. So that towards the end, yun na yung focus na tayo dun sa machine learning natin. Okay, so may I request you guys, ito notes muna on. So our lesson for today is we're going to do data splitting, okay, or we call it also resampling. So these are the methods that we use. There are different methods, guys. We'll just take a look at the 5 most popular ones. Okay, yung model 1 natin, guys, this is the one that we did just a while ago. Yung we split the data into 2, into test and train data. Okay, others would include another one. So i-group nila into 3. Test, and then validate, and then train data. Okay, but we'll just use the test and train method. And then model number 2 is called leave one out, LOOCV, cross-validation. I'll explain later on what this LOOCV does. No? Okay, parang test and train din data din yan. Okay, sometimes it's called jackknifing. Okay, let me just jackknifing. Okay, it's also called jackknifing. I think tama naman yung spelling ko. Double K ba to? Okay, anyway, check na lang natin. And then model 3 is your K-fold. K-fold cross-validation. Ito yung pinaka-popular. At saka itong repeated K-fold. No? May advantages itong K-fold cross data validation. And lastly, we have the bootstrap. And particularly using the 632 method. Okay, so these are the 4 sampling methods that we're going to discuss this afternoon. Hopefully, we're able to finish this. Okay, so hindi naman sa lahat, guys, ng 200 rows of code kasi karamihan dito, marami akong linagay na notes dito so that you can still review this on your own, even if outside the class. Okay, now why is resampling important, guys? Resampling is, when we say resampling, it means that we're not going to use everything in the data to come up with a model. Okay. The problem with using everything in the data, as I said a while ago, is overfitting. So, ano yung overfitting? Pag ginamit natin kasi lahat, guys, yung ng data set natin, and then when we introduce a new set of data, okay, chances are it will not be able to describe yung or predict yung based on the new data that we're using. Okay, so therefore, because it's overfitted, no? Okay, and because of that, guys, may impact on generalizability of the model. As much as possible, di ba gusto natin na generalizable yung model, which means that any new data that comes in, our model will still work given the new data. Okay, so for today, guys, we're going to make use of the heart failure data. I got this from Kaggle. Okay, pero binigay ko na sa inyo, guys. Okay, so kindly import the data. Import na natin. I think na ano ko na. So I'm not going to import it anymore kasi na-import ko na. Okay, here, 299 observations, the heart data. So kindly, guys, kindly import it. import the data and then load it. So here, I'll show it. Okay, marami siyang variables, no? 299 observations. Okay, I'll give you guys a few minutes to load your data. And once you're done, kindly please please chat yes. Okay, which means that you have uploaded the data in our markdown file. Okay, thank you, Masahiko. Let's wait for the others. Okay, thank you. So let's a few more seconds, guys, for the rest to be able to follow. Okay, good. Good. So I hope the others will follow suit, or I hope the others are also following along with this analysis. All right. So if we take a look at the heart data set, so we have age, we have anemia. So this seems to be a categorical variable, 0 or 1, kung anemic yung tao. Okay. And then we have this. So medical yung tinitingnan natin yan, no? Diabetes looks like this is also a factor. Okay, and then high blood pressure, kung mataas ba yung blood pressure niya, etc. Okay, and then sa dulo, okay, so this was the patient, the vital details of the patient were obtained. Okay, kinuha yung BP, yung platelet count, yung creatinine, etc. Siyempre yung details like yung gender ng tao, kung smoker ba siya. Okay, and then re-record kung if the person died. Okay, if the person died. So here we would like to predict, given this information, okay, will the individual die or not die? So because of the heart attack. Okay, so again guys, makikita natin dito yung usefulness ng model na to sa medical field, no? Sa medical field. Okay, so let's go back here. Okay, let's take a look at the structure of our data. Okay, data frame siya. Okay, so okay. Now guys, kasi I ran this a while ago, no? So you'll be seeing a different so yung mga ano niyo guys, yung mga factors, hindi pa siya factors, ano? Can you please tell me kung integer pa rin lumalabas yan? Yung class ng data like sex, smoking, death event, are they classified as integers? Could you kindly chat please? Naka-integer ba yung natin, yung mga categorical variables? Okay. So since it's yes guys, then we will have to convert. Okay, you know this guys, di ba? Okay, ito muna, no? So I always forget guys na let's see first, let's have a quick analysis of our data. Cross tab yung death event at saka smoking, no? Okay, let's see. Sabay na natin. Okay, so we have a cross tabulation. Okay. Okay, dito, okay, if we just base it on smoking guys, kung mag-aano ba siya, kung mamamatay ba yung tao kung smoker siya. Hindi naman, no? Kasi ito, hindi naman namatay yung individual na dinala sa ospital due to heart ailments. 137 in fact did not, tama. 137 guys who were non-smokers survived. 66, wait, yeah, hindi namatay. There were 66 who did not die, of which one was a smoker. Okay, sorry, baliktad. Of the smokers, guys, 66 did not die. Okay, dito naman yung mga namatay, one died. So, smoking, hindi sila smokers pero 66 namatay. Tapos, smokers sila, 30 namatay. So, quite a big number here, yung mga namatay. Okay, also the non-smokers, kahit non-smokers, they also died. So, it doesn't mean, guys, na non-smoker ka, automatic you'll die. Kasi dito, in fact, mas maraming non-smokers, 0 non-smoker to, are died. Okay, when they were brought to the hospital for suspect heart condition. Okay, ganito din guys sa diabetic, sa mga diabetes. Okay, walang diabetes pero namatay, 56. May diabetes pero namatay. Okay, again, we just can't base it on smoking and diabetes separately, individually. We have to take a look at the whole, thank you. We have to take a look at the whole picture using the different variables. Okay, so here, guys, kinonvert ko lang yung ano ba yung mga factors, ano ba yung mga response variable, yung mga predictor variables na factor dapat, anemia, okay, diabetes, high blood pressure, yung sex, smoking, at saka death event, all of them were converted into factors. Okay, so when you run this, pag-rinan nyo to, tapos tinan nyo guys yung structure ulit here. When you run the structure of the heart, okay, it will appear this way. So magiging, yung mga integers kanina, magiging factors na siya. Okay, pause muna ako. Okay. So far, guys, clear? Any questions?
Usually.
Okay. All right. Okay, thank you. Good. Now, transfer nga natin tong ito. Control X. Yung data validation, ito ilagay natin dito sa bandang data validation. Ay, sorry. Okay, cross-validation, Control X. Let's transfer it here, guys, sa model number 3 na lang. No? Ito, I'll put it here. Just kindly transfer it, guys. Mukhang na-display yung notes ko about cross-validation. And then let me just put this to row 40. Okay. All right. Now, we need the caret package. No? Ano ba yung caret package, guys? Caret at saka 1071, but more so with the caret package. So let's see. Tingnan muna natin yung caret package ito. Wait. I-check nyo nga, guys, kung may na kayo, kung may caret package. Mag-library muna kayo dito. No? Library, caret, and please give me feedback. Huwag nyo muna install, tingnan muna natin kung naka-install na sa inyo. So mag-library kayo, dito na lang sa console natin, library and then caret. Okay? So I hope hindi pa siya naka-install. Kindly check, guys, if you have already the caret package. Okay, good. None. Okay? So, okay, kung none, guys, dito na lang, wag niyo muna install si caret, no? Ang install niyo muna si Packman package. So may package na Packman. So may Let me see. Most probably hindi pa siya na-install guys. Packman. Sa mga package dapat. Packages. Packman. Okay. Okay, so si Packman package guys, ginagamit yan sa as a tool for managing packages. No? Okay, so kindly install first the Packman package. Okay, dito since hindi pa nyo pa na dapat kasi sa akin na-load ko na-install ko na yan. Kaya ang gagamitin natin p install. Okay, so these are some functionalities of the Packman package. Ito installs and loads the packages. Yung kanina ginawa ko guys, p load, no? Ibig sabihin nun, ilo-load lang niya. So yung p-load ang ginamit ko kasi na-load ko na tong Caret at saka 1071. But in your case, since hindi nyo pa na-load yung Caret at saka 1071 package, so this can be a shortcut guys, especially kung marami kayong, instead of just having yung library at saka install that packages, lumped into one na to, no? Packman. Okay, of course you can, pwede yung hindi na isulat to, no? Yung Packman na package na to. I just wrote it here so that alam natin it's coming from the Packman package. When I run library Packman, okay lang yan. Okay lang if it's not if it was built under 4.1.2, it's okay. All right, so p underscore install and check nyo guys kung mag-i-install at saka maglo-load at the same time si Caret at saka 1071. Okay, and then please check kung okay siya. Any chat guys, please, if okay na, no? Okay, I'm waiting for the others, guys. Not found, but I can manually call for each packages type. So iba naman, I get this wrong number when I run error in Packman install Caret 1071 not found. Okay, nag-error siya, guys. Pag rinan nyo to, yung install. How about the rest, guys? Some of your classmates chatted here. Okay, sabi ni Masahiko na it says object 1071 not found. Manually call for each packages tab. Okay. All right. So, okay. May mga packages kasi guys na ano na I notice also when I use Packman, pag yung mga packages deprecated na, ibig sabihin napalitan na ng iba. Kasi originally itong 1071 na yan, okay? It's used for machine learning and originally it was capital E, no? Tapos minsan pag binabago na nila yung package, nagkakaproblema na dun sa paggamit ng kunyari Packman for package management. Nagkakaproblema na. So when that happens, guys, ano na lang, no? Tama si Masahiko, sabi niya, manually install na lang. No? Either install here from the package, no? For example, ito ilagay ko dito E1071. Okay, so makikita natin dito, no? Yan. Package and then sa search 1071. Okay, formerly capital E 1071 by Wen2, no? The author. Okay, so that's version 1.7.9. Okay, anyway, if this does not work, guys, this is only good, especially pag maraming masyado, no? So this is a convenient way to install and to load at the same time. Unlike yung dati, di ba, pag naglo-load tayo, tsaka nag-install tayo, tsaka naglo-load, di ba? Install that packages, you have a long list, kunyari 10 yan. So isa-isahin natin, and then tapos library na naman, di ba? Pag maraming packages ang ginagamit. But this is actually a smoother, a more efficient way to do it. Okay, but again, guys, sometimes based on your experience then, especially pag na-deprecate na yung lumang package, no? Okay, nagkakaproblema. Pag ganon, manually install na lang. Okay, how about the rest, guys? Okay na-install na ba si Caret? Si 1071, hindi pa naman na pang ano lang to, pang trial lang ano. I tried it on a deprecated package. Yung ibig sabihin napalitan na dati capital E 1071 yan. Ngayon ginawa ng small e. Okay, all right. So far, guys. Okay, sige. Iba sa inyo. Pero yung Caret ba, nag-load siya? Nag-load yung Caret using Packman. Kasi pag tinanggal natin to, for example, tinanggal natin yan. Okay? Install and load. If I run that, medyo mabagal na, guys, gumana yung PC ko kasi medyo I was already informed that I should be deleting already some files, so hindi ko pa na-delete kaya medyo ang bagal niyang mag-run. Okay, still running. Okay, while it's still running, guys, let's open yung Caret dito sa information. Okay, Caret. Okay, so what is this package all about? So you can, of course, guys, maganda yung sa yung mga vignettes dito, yung a short introduction to the Caret package. Tignan natin to. Source. And it will give us the the Caret package, short for classification and regression training. Classification CARET, Caret. Contains functions to streamline the model training process. Take note, no? To streamline the model training process for complex regression and classification problems. So the Caret package is a very powerful package that can be used for complex regression. The package utilizes a number of R packages, but tries not to load them all at package startup by removing formal package dependencies. Okay, so you can read on this, guys, kung ano pa yung mga functionalities ng ng Caret package. Maraming ano yan, maraming okay, may example dito. For example, split the data into two groups, a training set and a testing set. Okay, we can use this create data partition. Okay, so yung ginawa natin dati, guys, di ba nag-index tayo? Okay, you can use the Caret package to split the data by using this function, create data partition, and example to, no? Library Caret, library ML bench. ML bench, guys, is a machine learning bench. So yung data na sonar nang galing doon. Okay, so ito, it's creating an object called inTrain. Okay, and then it uses the function create data partition. Okay, yung data natin is y is equal to from the sonar object, and then the class variable. Okay, and then ito yung P75, ibig sabihin ito yung proportion, no? 75% yung sa partition ng para sa isa, no? And then list is equal to false, ibig sabihin ayaw natin na naka-list siya, rather we want it to be a vector pag pinakita sa atin. Okay, and then this one, okay. Okay, so very simple lang, guys, no? Very simple tong you can try this, guys. I'll leave you guys to try this yung sa documentation ng Caret package. So it's very helpful for partitioning the data. Okay, there are other examples here. Okay, so other examples. Ito mamaya i-discuss natin yung train control, no? We're going to discuss what the train control is, okay, etc. Okay, so let's go back to our example. Okay, so model 1 natin, guys, yung similar to what we did last time, yung train and test data split natin. Error, Paulo, sorry, Paulo, could you, ano nangyari?
Sir, it still gives the same object 1071 not found, even after installing the package, sir.
Okay, did you manually install it?
Oh, yes, sir, with the window on the bottom right.
Dito sa packages, no?
Oh, yes, sir.
Okay, so when you wrote here E1071, ano nangyari? Hindi nag-appear tong ano?
Oh, sir, I haven't checked the 1071, but it's still giving me the same error.
I'm sorry, what do you mean?
When I try to run the Packman p_install code, it still gives me the same
okay.
object 1071 not found.
Okay, in that case, don't use the Packman package, no? Just manually install it. For example, di ba, how do we install packages? Pwedeng install that packages na lang, no? And then E1071. Okay, could you kindly try that?
Yes, sir.
How? And then tell me if it's okay.
Okay, I'll try it, sir.
Sige, okay.
It's installed.
All right. Okay, so let's go here, guys. So the one that we did before, it's also called a holdout method, no? Referred to as the hold. I think my dash dapat yan. Let me just.
Still the same error, sir. Sorry.
Hindi pa rin nag-install.
No, sir.
Okay, even if you use install that pack, anong message ang nakalagay?
It says, sir, a package successfully unpacked and MD5 sums checked. But when I run the code, it still gives me the same errors.
Ito yung Packman?
Yes, sir.
Wag na. Pag na-install na yung ano.
Okay, I don't need to run anymore.
Yeah, that means that the Packman package is not able to install yung E1071. No? Siguro, kasi hindi pa na-update yung Packman package, So hindi niya nababasa siguro yung E1071. Kasi remember, I showed you a while ago that bago na yung E1071, the old name was capital E1071. Okay? Maybe if we use, kaso deprecated na yung capital E1071. When we say deprecated, hindi na siya nag-work, no? Okay, so as I said, guys, you can do this, yung Packman package na to, and automatically install and load at the same time, no? Itong p-install kasi. However, there might be some packages that where we will be encountering errors or problems. Pag ganun, guys, manually install na lang. Either you use the package environment here, or you just install it directly. Install that packages and then library. Okay, Pao, did that answer your question?
Yes, sir. Thank you.
Okay, thank you, Pao. Okay, so this is just a review of what we did last time. Yung kanina, di ba? Nag-data split tayo, nag-partition tayo into training and testing. Okay, so medyo ano yung spacing niya? Sorry. Okay, so what's the train test split all about? It's the same to what we did. No, we split our data into two, okay, into training and testing. So it can be 80-20, 75-25, 70-30. If the data is big, then you can use a lower partition rate. Let's say 50-50. Suppose you have 10,000 observations, then it would be no problem if you do a 50-50. But for a small data set, okay, you would usually give a bigger percentage to the training data set. Okay, so let's go here, guys. Okay, so you know what set that seed so that we have the same partitioning. Set that seed 1, 2, 3, 4, 5. Then we're creating an object called in. Okay, and then we're sample 2 samples, and then n row of heart. Replace is equal to true. Probability 80, 20%. Okay. Of course, you could use the from the caret yung create partition. No? Ano yung nakalimutan ko yung function mismo. Let me just write that. Create oops, walang sumunod sa data. Okay, so hindi niya mabasa. Sige. Okay, so any questions about this code, guys? About this code chunk? So here we're creating an object called train, and it's coming from your heart object. And then we're subsetting only those that are equal to 1. Okay, so in test natin, subset then only 2. Okay, so when we run this, and then we now have a as an test. Okay. 299, sana siya? Okay. Shoot mo ito. Remove ko na muna para mabawasan dito. Oh, sorry. Ay, mali. Oh boy. Wrong mistake. Okay. Wala. Bad move on my part. I deleted everything. I forgot that there were some data loaded there. Anyway, quickly, guys, quickly. Let me just access again the file. Okay, heart. Okay, heart name, heading, okay. Import. All right, so let me just I'll just run those that are relevant ones. Okay, this one. Okay, so Carrot is still uploaded. Okay, and this one. Okay. All right. So we now have, guys, Heart has 299 observations. So we're loading 80%, 20%. So 80% is around 228 and 20% is around 71. So we were able to split our data into train and test data. May question ba? Okay, Masahiko, are there specific cases where replace will be false po, or is it dependent on the data or the case? What do you mean, Masahiko, by false? Masahiko?
Hello po, sir. Sorry.
Yeah.
Uh,
What
are
do you mean
there
by false?
like the replace equals true po, diba?
Oo.
Are there times when people use false
Yeah.
instead?
Oh, yes. Yes.
Okay.
For cross validation. In cross
Okay.
validation, ano yun? We don't replace it. No? Okay. Here I'm using true. Okay. This is more of bootstrapping. So there are different ways, as I mentioned a while ago, there are different ways to resample, to split our data. One way is the k-fold cross-validation. Here, the resampling, resampling is equal to false, which means that once you have put a data, an observation in one group, it cannot be part of the other group. So that's an instance where the replace is equal to false. For bootstrapping, the resampling is equal to the resampling is equal to true. So which means that an observation can become part of it can be how do I say it? It can be used twice for your training data. Okay. Did that answer your question, Masahiko?
Yes po, sir. Thank you.
Okay, thank you for that question. Very good question. Salamat, no? Okay, so let's move on, guys. So replace is equal to true. Please take note when you say replace is equal to true. Let me explain this again. So you have let's analogize it. So for this data set, there are 299 observations. So you put observation 1 up to 299, you put it in a, let's say, container, okay? And then you draw out one, so let's say observation number 50. So you list that observation number 50, this will go to our sample 1. But you return some observation number 50. You return it back to the container. So which means, and then let's say you mix the elements in a container, there's still a chance that observation 50 will be once again chosen. Okay, so it's possible that observation 50 will be recorded twice in your training data set. Okay, and that's what happens with the bootstrapping. Okay, but not with the cross validation. So that's a very good question, Masahiko. Thank you so much. Okay, so we have now test and train data. Okay, and then let's now fit a logistic regression on that. So let's call our model 1. This is just similar to what we did last time. At the start, you have our dependent variable is death event. Okay, 1 being the person died, 0 being the person did not die, and then we're regressing it on all the predictors. Okay, and then comma. Our data is equal to, we're using now the train data. Okay, the train data, which has 228 observations, and family binomial. Okay, remember guys, this is GLM, generalized linear model. Okay, we use this when it's a binomial, binary logistic regression, or multinomial, or others, so on, etc. So let's run this. That's our model 1. Okay, and then so we have now model 1 here. Okay, Okay, I won't go anymore into coming up with the confusion matrix for the trained data. Okay, I know you know how to do that. Let me just go direct to using the model one to predict our test data. Okay. Okay, I hope guys you see the gap here. I won't anymore because in our example we still predicted we used the model to look at the predicted values for our trained data. Here, the direction na tayo sa test data. No? We'll see how our model fared with respect to the test data. So the code is P1 predict, okay, using the mod 1. New data is equal to test data, okay, and type is equal to response also. So let's click this. So we now have P1. Okay, so these are now the probabilities. Okay. 0.937, 0.855. If it's greater than 0.5, it means 1. Okay, it means the person died, right? Okay, and then we just change. Okay, we change our P1 into if it's greater than 0.5, then we make it 1. Otherwise, we have to make it 0. Now, again, this is the first time we're using this. Itong as factor na to. No? Okay, kasi yung ano natin, yung object predict 1, okay, if it's numeric, guys, hindi mag-work dito sa confusion matrix sa caret. Okay? So here, unlike the one that we did before, yung unang model natin logistic, yung review natin kanina, nag-predict tayo, di ba? Pero hindi natin ginawa natin as factor. Okay, kasi guys, yung confusion matrix natin ngayon, gagamitin natin yung confusion matrix ni caret. Okay, let me repeat that, guys, just to make sure that we understand that. Di ba, we reviewed this, ito, kanina, di ba? Okay, this one. Di ba? Itong predict 1 natin dito, if else tayo. No? If else, if P1 is greater than 0.5, make it 1, otherwise make it 0. Okay, and then, nag-confusion matrix tayo. Ang ginamit natin, guys, yung table function. Yung table function ang ginamit natin. Now, limited lang makukuha natin dito, yung count lang. Okay? Now, that's why, when we do resampling, it's better to use the caret package because it will give other very valuable information, other valuable metrics. So dito, predict 1, as factor natin the result of yung P1 na prediction natin, where we make, pag sinabi natin greater than 0.5, equal to 1 siya, otherwise 0. Okay, so let's run this. Okay, so ito na yung predict 1 natin, no? So ito na yung mga predictions, 1, 1, 1, 1, 0, 0, 1, etc. Okay. So take note, guys, this is already for the testing data. Ano ba si predict 1? It's a and factor na siya, di ba? Factor na siya. Okay. So tingnan natin ulit. I-run ko lang tong, click ko lang tong predict 1. Okay, hindi. View na lang. View pred 1. Okay. All right. Ito, guys, yung mga predictions, diba? 1, 1, 1, 0, 0. Yung 0, guys, hindi namatay. Yung 1 namatay. No? Okay. So 71 entries siya. Bakit 71 entries? Kasi, guys, this is already the prediction for your test data. No? Again, guys, we did not anymore compute for the confusion matrix of our trained data. Dumiretso na tayo sa test data. Okay? All right. And guys, di ba, yung test data natin, 71 observations. Now, take a look at this, guys. Kanina, hindi tayo nag-confusion matrix using caret package. Dito, gagamitin natin yung confusion matrix ng caret package. No? So, data is equal to, okay, pred 1, ito na yung zeros and ones. And reference natin, okay, yung test, and then $death event. Okay? Di ba si test data natin, yung variable natin dyan, yung death event, it's the actual value. Let's look at that. Ito yung test data natin, ano? Dito sa huli. Ito yung death event natin. It's the actual 1 or 0. No? Ito yung actual record kung namatay yung individual or the individual survived. No? So we named it death event para ang 1 dyan yung namatay. No? Para clear sa atin. Okay, so going back, let me just... Okay, so i-run natin guys yung confusion matrix natin. Run. Okay, ba't ako nagkakamali? Could not find the function. Okay, sandali ah. Ibig sabihin natanggal yung caret ko. Okay. Run again. Okay. All right. Take a look at this, guys. So, sino mas magandang results? Yung result natin kanina na manually kinumpute lang natin yung yung confusion matrix, or the confusion matrix results output provided by the caret package. May I have a feedback from you guys? Which do you think provides a better output? Yung kinumpute lang natin yung confusion matrix natin using the table function, or using the caret function, the caret package, specifically the confusion matrix from the caret package. Okay, ano answer, guys? I see only 2 answers, guys. I hope the others will respond. Na-generate nyo ba itong Were you able to generate the output for this code chunk, yung confusion matrix? Yes, thank you. Thank you, Masahiko. Thank you, Aubrey. How about the rest, guys? Nakasunod ba kayo? Let me know, guys. Haven't heard anything from us to that question from 15 students. Pwede bang pwedeng feedback, guys, kung na-solve yung confusion matrix. Otherwise, guys, kung hindi, i-solve natin. Solve natin ulit. Kaya natin re-review kanina yung yung simple natin yung logistic regression natin, where we just computed for the confusion matrix using the table function. And then I'm showing you here now the caret package giving us a very rich output for the confusion matrix. Okay? Yung iba hindi pa sumasagot, guys. Nakuha nyo na ba yung output na to? Paki-chat please kung yes or no. Otherwise, I'll repeat, guys, the discussion. Please. Na lang. Okay, thank you. Sana iba, guys, Okay. Now, I'll just show you guys ito If we remove the as factor here, tanggalin na natin if as factor dito. Okay. So if else lang din, no? If else. Okay, let's see. Let's run this. And then let's run the confusion matrix from the caret package. Okay, there, guys. Error. Data and reference should be factors with the same levels. Okay? So, kasi yung pred natin dito, ito guys, yung pred natin yan, if we get the class of that pred one, okay, di ba numeric siya, no? So, it did not work. A minute, guys, just a minute. Okay, sorry guys, I just answered a knock. Okay, so hindi pa pwede ng ganito, no, di ba? Kaya natin dapat so ito as that factor data. So this is a nuance of concurrent package. Then close this. Okay. Right, so ibalik natin to. Okay, so factor na si Fred 1, okay na tayo. And then i-run na natin tong confusion matrix. There. Okay, so we will not guys, we will not discuss all the things here, but I left you a very good site, very good reference for you to read and understand yung ano no, yung ano yung ibig sabihin nito. Okay, we know the confusion matrix, no? So ito yung true, negative. Let 0 be negative. This is true negative, and then this is true positive. Okay, this is the false ano to? False negative. So 0 is negative. False positive. Okay, so where does the 84% accuracy come from? Saan nanggaling yan? Yung 84.51%. So that's simply, diba, yung sum lang yan, sum ng 44 at saka ng 16, yung mga tamang predictions, and divided by add na lang natin guys, 44, 7, 4, 16, that's 71, di ba? That's the total. Okay, so 84.51. So that's the accuracy. No? Ito yung tamang predictions, guys. That's the accuracy. And then here you have additional stat. In confidence interval natin, we are 95% certain that the correct predictions lie between 74% and 92%. Okay. No information rate. Ano ibig sabihin, guys, ang no information rate? What does that mean? Ano kaya ibig sabihin nito, guys? Okay, I want you to find this out. Pero madali lang yan, guys. No information rate. Okay, what if we did not use this? Hindi natin minodel to. Tapos ang ginawa na lang natin, guys, natin structure. Ano ba yung structure ng ano natin? Ng test. Test, summary. Asa na si Amelia? Okay. Si Death, no, guys? 48 and then 23. Okay, 48, 23. So, let's suppose we're not going to use the model. So, paano natin i-predict? Eh, since mas marami hindi namatay, no? Did not die. Okay, we'll just predict everything with did not die. Don't use the model, not anymore. Let's just determine how many in our test data set did not die or how many died. Okay, since mas maraming did not die, then ang prediction na lang natin, did not die na lang lahat, di ba? You get me, guys? We'll just predict that everyone did not die. So if that's the case, then 48 yung tama natin divided by 71. So ilan yan, guys? 66.61. Yun, guys. That's the, okay. Okay, yun. No information rate. Yun ang ibig sabihin nun. Had we not used the model, okay, had we just used kung sino yung pinakamalaki dun sa ano sa dependent variable natin, in that case, Di ba ito, yung 0.48. So sabihin natin, let's let's do away with the model. Let's just predict that all people will not die. Okay, so what was our accuracy of that because of that decision? 67% tayo. Of course, when we use the model, 84% yung tamang prediction natin. Okay, so there are other things here like kappa, guys. This is very important. In the interest of time, guys, I want you to read on what's kappa. Ano ibig sabihin tong 63:38 na to? Tapos meron pa tayong McNemar's p-value. What does this mean? Okay, ito madali itong mga iba, no? Kunyari, yung sensitivity. What does 91.67 mean? Ano ibig sabihin ng sensitivity? What does that mean, guys? What's sensitivity? 91.67. Any guess kung saan ang galing yan? Yung sensitivity na yan? What do you think? Any suggestion? Okay, sige. Since kulang na tayo sa oras, no? I'd like you guys to, okay, ito may binigay akong source. Okay. If you'll copy this. Gusto nata itong medyo mabagal na guys yung ano ko. Okay, anyway. Okay, kindly look at this guys, at this side, and then hanapin nyo na lang yan. Tapos may explanations dyan. Maganda yung mga explanations dyan. What are these? What are these values? Tapos pinakita niya yung formulas. Okay, so that's a very good resource. Although ang ginagamit dito ano yung Python, no? Pero okay lang 'yon. Importante naman yung concept eh. Okay, so next guys. Okay, I think we have time to just to discuss this method 2. So bukas guys, kung pwede paki-run na yung iba dito, yung k-fold. So I think we can quickly do yung mabilis lang naman 'to eh. Ano yung leave one out cross validation guys? What's that? What's leave one out validation? Yung leave one out validation, ang ginagawa dyan, so we have, ilan yung observations natin? 299, ano? 299. So iba yung partitioning nito. No? Yung 299 observations natin, ang ginagawa natin dyan, so gagamitin natin yung 298 na observations, yung isa, i1, no? Okay? So ang training natin, ang train data set natin, yung 298, tapos yung isa, i1. So magma-model. So magkakaroon ng result. Tapos again, yung second element, siya yung tatanggalin, no? The rest will become part of the training data. So in other words, guys, each one of the elements in our 299 observations will have a chance to become a trained test data. Okay? So imagine guys, ilang ano to, ilang models bali ang gagawin. Ilang model ang gagawin? 298, no? N-1. Okay? There will be 298 models where 298, okay, will become part of your training data and 1 will be your test data. Okay, so uulitin yon hanggang each and every element of your data set becomes a test data. Okay? So yun yung LOOCV guys, leave one out cross validation. Okay, so how do we do that, guys? So we create an object called LCV. This is leave one out cross validation, and then we're going to use the train control function. A train control function. Okay, and then method is equal to leave one out cross validation. Okay, and then from there, gagamitin natin yung train function. Lahat to guys sa caret to, no? This is how caret does it, no? Okay, so after creating this LCV, yung train control na to, kasi gagamitin natin yung train control na yan dito sa TR control dito. Okay, so we create an object model called model2. Okay, and then we use the train function. Our dependent variable is that event. Regress natin sa lahat, comma, data is equal to, okay, dito guys, hindi natin ginagamit yung test and train, no? Kasi ito, lahat ng data natin gagamitin para dito sa LOOCD, no? Okay, so iba to kaysa dun kanina, dun sa in-split natin dun sa train and test. Dito ang splitting natin, isa yung ini-split natin. Gagawin siyang test data. Okay, so since there are 299 observations, each of them will become a test data. Okay, so there will be 298 models. Again, method GLM family is equal to binomial. TR control, the train control is equal to LCV. Okay, so let's run this, guys. Let's run this. Tingnan natin kung ano nangyari. Error, ba't ako nag-error? LCV, hindi ko pa nararun si LCV. LCV, and then there. Okay, it's taking some time kasi syempre 298 ano yan eh. 298 models, no? So it depends on how fast your machine is. Eh lalo na guys kung let's say 5,000 yung 5,000 yung sample size natin, di ba? Imagine 4,999 ano yun? 4,999 models. Okay, nagrun na siya. Print natin si model 2. Okay, so ganun din guys, no? Ganun din. Kaso ang ibibigay lang sa atin dito yung accuracy, no? Ang accuracy natin 82% as compared to kanina yung 84%. Okay? So that's ito yung result ng leave one out, no? Cross validation. Okay, ito naman guys yung time na pala, no? May I have guys 1 minute lang, 1 or 2 minutes, okay lang ba? Permission guys. Permission to no hard feelings. Oh, wala naman sigurong hard feelings, ano? Okay. Ito guys, access lang natin. Ito kailangan kong mapakita sa inyo. Sana maano ko siya. Hindi ko nakaka-copy kasi ano ba ang problema ko nito? Ang dami ko na kasing open. Kailangan siguro mag-close na ako ng ibang ano. Okay, hindi na siya. Yan. Okay. Quickly opening this. I'll just explain guys yung k-fold. Okay. So although Python to, no? Python. Pero ang ibig sabihin ng k-fold guys, okay, this is an example of a here. Ito to. Let's take a look at this. Okay. So this is a five-fold cross validation. What happens? So dito guys, ito yung all data natin. Split muna natin siya into training and testing. Okay? So parang pareho ng unang method natin. Split siya and then ifo-fold natin yung si training. Anong fold? Kunyari, 5-fold. Ibig sabihin, we're going to split it 5 times. Okay? So, paano yon? Paano i-split? I-split natin yung data natin into 5. Yung training data lang, ha? So, 1, 2, 3, 4, 5 yan. Tapos, each of them will be used as a testing data. The rest are training. Okay? So, itong fold 1 na to, hihiwalay natin yan sa training data kasi gagamitin siyang testing data. The rest will be training. Split number 2 naman, okay? Kuha nyo guys. So each of the folds here will be used as, will have a chance to become part of that training data and part of the testing data. Okay, yung mga blue dito, sila yung mga testing data. Tapos may mga results yan bawat fold. First fold, second fold, o split ang tawag nila. No? So 5 split kung 5-fold validation, cross-validation. And then i-average lang yon yung result na yon. Tapos yung result na yan ang gagamitin to test your data. Okay? And then, basahin nyo lang guys kung anong advantages ng K-fold cross-validation. Okay? So, iba't ibang klaseng K-fold cross-validation din. Okay? Alright? And lastly, pakita ko lang guys kung ano. Ito, pakita ko lang kung ano nangyari dito. Okay? So, set that seed tayo. Okay? Any number to. And then, mag-create tayo ng train control. Parang yung kanina. No? Kanina LCV tayo. Ngayon, let's call it KCV. K-fold cross-validation, and then number 10. 10 folds to. No? So 10 splits to. Bakit 10 guys? Based on experience, based on research. No? Ang sinasabi nila na maganda rin ang pinakamaganda, yung medyo na minimize yung variance is yung 10-fold. Of course, pwede nyo namang experiment yan, 5-fold, 6-fold, 10-fold, etc. So let's run this. Last na. Okay, and then i-model natin, okay? Again, ito guys, papalitan natin yung train control ng KCV. Naka-link dito. Okay? Run this. So, i-print natin si model 3 natin. Okay. So, ito ang accuracy niya, 82 or around 83%. So, hindi masyado nagkakalayo dun sa kanina. No? Okay, and then I want you guys to read on this, yung pwedeng repeated K-fold, at saka ito yung bootstrapping. No? Okay, so kindly run this guys, i-compare nyo na lang, tapos tingnan natin guys kung bukas kasi, di ba anong oras yung class natin bukas? 1 o'clock, di ba? Tama? 1 o'clock. Okay, sige. So, thank you so much guys. I hope you learned something today. Hindi natin natapos pero okay lang yun. I'll see you tomorrow.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Salamat.